Okay. So, in the last class we are discussing about 8259. So, I have explained the flow chart of the initialization registers. As I have discussed that 8259A uses 2 to 4 initialization command words. Okay. So, in that the ICW1, if I take the format of ICW1, initialization command word 1. So, the format is the last bit D0 bit of this one will decide whether ICW4 is needed or not. This is IC4. So, this will decide if this bit is equal to 1, if I call this one as D0 bit, if this D0 bit is equal to 1 implies ICW4 is needed. If this is equal to 0 implies ICW4 is not needed. As I have discussed in the flow chart also, this can be ICW4 can be is a optional one. Then the second bit D1 bit will be here, either it is a single mode or cascade mode, SNGL. This if D1 bit is 1 implies single mode. As I have discussed, this 8259 can operate in single mode as well as cascaded mode. So, in single mode we can have 8 different devices can be connected to 8259, whereas in cascade 64 devices can be connected. I will discuss how this 8259 will be cascaded to service 64 different IO devices. Then we have address interval ADI. So, the address interval of different types of the IRs, we can have either 4 or 8 intervals, okay, as I have discussed in the last class also. So, this if this bit is equal to, this is D2 bit, if this D2 bit is equal to 1, so there will be interval of 4 bytes. If this is equal to 0, then 8 bytes interval. But in case of 8086, it uses only 4 bytes interval. So, this D2 will be, we have to set to 1 in case of 8086. The next bit is LTM, level triggered or edge triggered. As I have told, one of this important feature of this 8259 is it will accept both edge triggered as well as level triggered interrupts. So, if this is one level triggered, this bit D3, if D3 is 1 implies level triggered, if D3 is 0, edge triggered. And the remaining 3 bits will be used for only this 8085, whereas in 8086 they will be don't cares. This is D4, D5, D6, D7. In case of 8086 they are don't cares, whereas in 8085 they have some different purpose, but here we are discussing about only 8086, they are don't cares. And D7 bit is A0. A0 of this 8259, we can see that one of the pins of 8259A is A0. And for ICW1, this A0 is equal to 0. This is equal to 1 for ICW2. So, this is about the format of the first initialization command word ICW1. So, this will decide whether ICW4 is required or not, and then whether we are going to operate in single mode or cascaded mode, and what will be the interval between the two successive interrupt vectors, 4 bytes or 8 bytes, but in case of 8086 by default 4 bytes, and it will decide whether the interrupts are level triggered or edge triggered. So, this information will be supplied by this initialization command word 1. Then coming for this second initialization command word ICW2. So, the format of this ICW2 is this is also 8 bit register D0 to D7, D0, D1, D2, D3, D4, D5, D6 and D7. So, the last bits are A8, A9, A10, A8, status of A8, A9 and A10. Then the last bits are T3, T4, T5, T6, and as I have told, D7 bit is 1 for ICW2. So, there will be one more bit which is called T7. This is 9 bit in fact, D7, D8. So, these bits in case of 8086 will decide the type of interrupt. As we know that in case of 8086, this will decide the type of interrupt. So, we know that in case of 8086 there are 256 types of the interrupts, type 0 to type 255. This we have discussed while discussing about the interrupt system of 8086. So, in order to have 256 different types, we require 5 bits. So, these 5 bits T3 to T7 will be used for selecting the type of the interrupt. So, if it is type 0, all bits will be 0, these bits will be 0, 0, 0, 0, 0. So, that we will get type 0. If all are ones, we will get type 255. In between, for different combinations, we will get different types of the interrupts will be selected. Whereas this A8, A9 and A10 will be used for generating the address of this 8259. That we will discuss while discussing about the interfacing of 8259 to 8086. This is ICW2 format. So, this ICW1 and ICW2 are mandatory, compulsory. As it is clear from the yesterday's flow chart also. Whereas ICW3 and ICW4, are optional. ICW3 will be used for cascading mode, which is clear from the yesterday's flow chart. So, in this ICW1 we can decide whether ICW4 is required or not. So, before going to discuss about this ICW3 which is required in cascading mode only, I will discuss how the cascading of 8259s will be performed. So, I will first discuss about the cascading of 8259s and then I will go to ICW3. So, here in this case one master has to be present. If I call this one as a master 8259, so we know that this will be having IR0 to IR7 interrupt requests, IR0, IR1, IR2, IR3, IR4, IR5, IR6 and IR7. And there is one INT signal. This INT signal will be connected to the INT of 8086. This is your 8086. This INT is connected to INT of 8086. So, this INTA bar will be connected to INTA bar of 8259. So, I am showing the connections of only the important signals, how this cascading will be performed. Then we have this A0 line of this one is connected to A0 and data bus will be connected together. We have D7 to D0, this will be connected to D7 to D0 of the lower order 8 bits of 8086 address data bus. Then if I use another 8259A, so with this also will be having 8 different IRs, IR0 to IR7, so we can connect one more. Like that I can connect a maximum of 8 8259As. This also will be having 8 different IRs, IR0 to IR7, like that. If I call this one as number 1, if I call this as number 2, like this number 8. This also will be having IR0 to IR7. Now the INT of this signal, this 8259A. So each 8259A will be having one INT. So this INT will be connected to IR0 of this or to any of this IRs of 8259A master. This is called master. And these are all called slaves. And the INT of master is connected to 8086. So the INT of this one is connected to IR1, so on up to INT of the 8th 8259 will be connected to IR7 of master. Now totally how many interrupt lines are there, interrupt request lines are there? This is having 8, this is having 8 and so on. We have 8 such devices, total we can have 64 interrupt request lines. So I can connect 64 different devices such as printers, IO, keyboard and all. Okay. Now the process is here. So whenever if any particular interrupt occurs over any of the slaves, say here at IR0 some interrupt occurs through some printer. So then under two conditions this interrupt will be accepted. One is this IR0 should be non-masked. So under two conditions, IR0 should be, whatever the interrupt that we are going to use, it should be unmasked. How to mask and all we will discuss in the initialization register. If it is unmasked is one condition, and if the priority of that particular IR should be high. Priority is highest. So what happens is this will recognize the request placed by the printer, then this INT signal will be activated. So this INT signal is connected to one of the interrupt request of master. Again the same conditions here, if IR0 of the master is not masked, which is unmasked, and the priority of IR0 is highest among all the serviced interrupts, then this master will place a request through INT to the 8086. Then 8086, after completing the execution of the current instruction, it will send a pulse on INTA bar. Of course this INTA bar is connected to the INTA bars of all the 8259s. So this will be connected to INTA bars of all the slaves. So as I have discussed in the last class also, so this INTA bar consists of 3 pulses. So first INTA bar pulse, for the first INTA bar pulse, this master will enable, whereas the slave simply neglects the first INTA bar cycle. So in response to the first INTA bar cycle, what the master will do is, so the master will place the ID of this corresponding slave. Each slave will assign some ID. I will discuss what is the ID of this slave in initialization command word 3. So each slave will be having some ID, that ID will be informed through CS lines. There are 3 lines. called CAS 0, CAS 1, CAS 2. This will be connected to the corresponding CAS lines of all the slaves. Corresponding signals of all the slaves. So, in response to the first INT A bar acknowledgement cycle, this master 8259 places ID. So, normally this ID is, if this is connected to IR 0, this ID will be 000. If this request is through IR 1, this will be 001 and so on. So, this ID will be placed on this CAS 0 to CAS 2, so which will be received by all the slaves. The slave which has initiated this interrupt, that will enable, now it will respond to the second and third cycles of INT A bar signal. So, the first INT A bar cycle will be just neglected by the slave which is initiated the interrupt request, whereas after receiving this CAS 0 to CAS 2, the ID of that particular slave, then the corresponding slave will respond to the second and third pulses of INT A bar cycle. So, in second and third what it will do is, so this will place the type of interrupt. So, which type of interrupt you want to perform by using this IR 0. As I have told, there are 256 types of the interrupts. So, that corresponding information has to be placed onto the data bus. The data bus of all the slaves will be connected together to the 8086. So, on the lower order 8 bits of this 8086 data bus, it will receive the type of interrupt that is to be performed. So, based on this type of interrupt, so the microprocessor will branch to the interrupt service subroutine, whose address will be calculated based on the type of interrupt. I have discussed this interrupt vector table. Correspond to each type, we have 4 locations. The locations of CS code segment and the location of instruction pointer. So, those values will be stored in a instruction interrupt pointer table. So, correspond to that address, the microprocessor will switch over to that location. So, that is the procedure of this cascading of 8259. Now, based on this cascading of 8259 operation, I can discuss now the initialization command word 3 and initialization command word 4s. Initialization command word 4. So, if I take the format of initialization command word 3, as I have discussed in the flow chart, ICW3 will be used only when cascading mode is performed. So, this ICW3, we have 2 different ICW3s, one for the master mode, another for the slave mode. So, I will first discuss about the ICW3 format for master mode. So, in ICW3, the last bit will be S0, S1, S2, S3, S4, S5, S6 and S7. And this is A0 and A0 should be 1 for ICW3. This is D0, D1, D2. D7. This is additional information. This is actually in fact not a pin of this 8259 format. This is not included in the register of this one, that is why this is 8th location. So, these pins this all 8 pins. This will be 1 if the input has a slave. I will explain what is meant by this. 0 if the input is not having slave. As I have just now discussed about the cascading of 8259. So, this is master 8259. So, this is IR0, IR1, so on up to IR7. If I connect a slave to this IR, slave 8259A, this is INT of this will be connected to IR of master, then this S0 bit will be 1, indicates that there is a slave connected to IR0. If this IR1 is there is no slave here connected, then IR1 bit will be S1 bit will be 0, indicates that there is no slave. If I assume that only one slave is there which is connected to IR0, then this bit will be S0 will be 1, remaining all bits will be zeros. So, it depends upon whether this IR0 to IR7 of master 8259 is connected to slave 8259 or not. This particular bit S0 to S7 will have a status of logic 1 or logic 0. 1 means the corresponding IR is having a slave, 0 means the corresponding IR is not having a slave. This is for ICW3 in master mode. ICW3 in slave mode, the format is this is ID 0 to ID 2, then we have all zeros, this is A0. As I have told, this A0 is not a part of this register. The register length is only 8 bit, D7 to D0. This is additional information. A0 is equal to, so A0 is one of the pins of 8259. This is 1 for ICW3 and this is 0 for only ICW1, remaining it will be 1. So, as the name implies, the ID, as I have told, the ID will be generated in response to the first INT A bar cycle. The master will generate ID. So, the ID number will be decided by these 3 bits. So, the ID number will be here. If these 3 bits are 0, 0, 0, the ID number is 0. If these 3 bits are, we have 8 combinations, 0 0 1, the ID number is 1. If this is 0 1 0, ID number is 2. 0 1 1, ID 2 is MSB, ID is 3, like that 4 5 6 7. This is ID number. This will be 1 0 0, 1 0 1, 1 1 0, 1 1 1. So, this is the ID generated by master 8259 in response to the first INTA bar cycle. This will be in slave mode. So, whenever this slave 8259 receives this ID, then it will respond to the second and third interrupt acknowledge cycles. It will give this the type of interrupt code on the lower order 8 bits of data bus of 8086. This is about the ICW3 in master mode and slave mode. Now, going for the ICW4. The format of ICW4 is, then we have 8 bits and A0 will take additional bit. This D0 bit will be microprocessor mode. So, this will be 1 for 8086 and 0 for 8085. The next bit is D1, which is AEOI. This is 1 for AEOI. The abbreviation of AEOI is automatic end of interrupt. Once the interrupt service subroutine is executed, then to indicate that the interrupt service is completed, so you have to use, there are 2 modes of this interrupt service end process to indicate the end of the service. One is automatic mode, so another is just simply manual mode. This is 1 for this automatic mode and this is 0 for just by default end of interrupt mode. I will discuss this in detail later. So, this is second pin. So, after the completion of the service of interrupt, so to show that, to indicate that the interrupt service is ended, so we can have 2 types of the this end of interrupt indications. One is automatic, another is EOI. So, this is 1 means automatic, 0 means EOI. And then third bit will be M by S bar, and fourth bits together this one buffer. M by S bar, this is master slash slave bar, and BUF stands for buffer. So, these 2 bits will decide. There are 4 combinations here using 2 bits. So, the corresponding operation is zero x. Zero x means this can be 0 0 or 0 1, and we have 1 0 1 1. This is 0x means this is non-buffered. So, what is meant by this buffering we will discuss, and this 10 means buffered in slave mode. And this is buffered in master mode. So, it is about these two next two pins, buffer and M by S bar. Then we have specific nested mode, as I have discussed in the last class. So, this 8259 can operate in 3 modes: fully nested and automatic rotation mode, specific rotation mode. So, that will be decided by this bit of ICW4. This is 1 means specific mode, specific rotation mode, and 0 means automatic rotation mode. As I have discussed these modes in the last class, in case of automatic rotation mode, the priority which is recently served will be given lowest priority, and then so in the order of these IRs the priority will be assigned. Whereas in case of specific rotation mode, the lowest priority can be assigned to any of the IRs by the user. So, these are the 5 bits, remaining 3 are don't cares, and this is A0 bit. A0 is equal to 1 for ICW4 also. So, using this initialization command words, so we will write later some programs. That time the operation of this ICW4, how to form this ICW 1 to 4 will be clear. Then in addition to this initialization command words, there are some operational command words also, OCW. So, we have 3 operational command words. So, we will discuss these operational command words in the next lecture. Thank you.